Ladies and gentlemen, please welcome CEO of Nexans, Kåberger.
Thank you. Thank you. Thank you to come here in Stockholm for this physical event. We are very proud to welcome you here in Sweden. First of all, let me thank you in the name of the Executive Committee of Nexans to welcome for this second event for our Climate Day. It was a year ago that we have launched the first Climate Day in Paris with hundreds of customers, experts and influencers that have everything in common is to address the main stake of the sustainable electrification. Open to various points of view with real will to debate on those stakes, I announced last year that Nexans on our hand will have every year a Climate Day. And very proud to be there in Stockholm. We always are willing to learn from experts. Global companies, influencers, regulators gather all together to make a climate vision a reality for the sustainable electrification. But before we go into details, let me tell you where we stand since last year in our commitment for climate change, which is the heart of our Nexans strategy, as we have announced that we will become a pure player in electrification. We have announced that in the beginning of the year, saying that we will move from 34 subsectors covered from automotive, telecoms, electrification, in order to only focus on the electrification activities. So it's a big change. It's a big change, but it's as well to say that being a pure electrification player gives us the ability to massively invest in those activities, which is the generation of electricity, the transmission of electricity, the distribution up to the usage of the electricity. So more than ever, Nexans will electrify the future. We made the choice to become what we do best. We need to understand that we are at the beginning of a huge electrical revolution that will involve the same level of investment as all investment made between 1950 and 1970, post-World War II. This is due to the fact that the generation of energy infrastructures and the power grid installation were built during that period. We need to manage in parallel two major issues for our planet. First, that we all know that the world is 80% still dependent on fossil fuels that need massively to be replaced by carbon-free energies. The average grid in Europe, and as well in the US, is about 45 to 50 years old. The aging of power grid in those regions is a concern, as the network cable lifespan, when it has been installed in 1970, was only about 30 years. Only 30 years. In other words, there have been significant underinvestment for the last 10 to 20 years, according to those regions. And the risk of power outages is increasing month after month. And this is not just a technical issue. The power grid is the backbone of a country's economies, like telecom, of course. The electricity travels through millions of kilometers of cable every day. When infrastructure fails, when you have a blackout, it does not mean direct asset damage, but life stops. You have no more telecommunication, no more Wi-Fi for your teens, no more heating system, but more importantly, you have no more access to water. Due to the aging infrastructure and the intensity of climate risk, each nation needs to massively invest to modernize and fortify this electrical infrastructure. You know, let me give you an analogy. It's like the telecommunication network. Everyone understands that in order to have a better quality of life, to have better digital stuff, we must dismantle the very old copper LAN cable that have been installed in the beginning of 80s, and to replace them by fiber optics leading edge technology that will allow everyone to have a higher telecommunication bandwidth, higher speed, and low latency. And of course, this shift from copper LAN cables to fiber optic enable the world, telecom world, to move from a 2G technology, 3G technology, 4G, and now we are talking about the 5G technology. It is exactly the same idea for the power grid. Exactly the same idea for the power grid backbone, except that this investment renewal have not been met yet. So I'm not announcing the end of the world, but I want to say that we are at a tipping point of a huge electrical revolution. And you know, a lot of things are moving. For example, we have, of course, a lot of national and regional commitment to carbon neutrality. Like I was in US last week, we talked with key experts about President Biden's Build Back Better plan, which is a massive investment in the power grid infrastructure and for as well renewable energy, either offshore wind or solar. You can read as well the commitment of President Xi Jinping for carbon neutrality by 2060. It's a massive investment in the power grid and massive investment in renewable energy. And of course, Europe is not lagging behind because Europe will announce, and is announcing already, billions of euros for renewable energy. So all those major decisions demonstrate an acceleration to move from planning to action. The demand of electricity will grow in average by 20% in the coming 9 years, 50% by 2050, because the world population keeps growing. And we need as well to accelerate the momentum of what we call the electrifying everything. Because electrification is the most effective route to reduce CO2. But despite record of growth in the renewable energy in the last months and years, the vast majority of the power is still depending on fossil fuels. So to change this paradigm, I believe that UK and Sweden are a great example. Great example to follow because both of those countries are on the way or have reached already 40% of power generation provided by renewable energy. Either we are talking about offshore wind or hydropower. So Nexans and its customers learn very quickly from Swedish and British experience. And we have learned as well in UK in terms of wind offshore development. And I think, like Sweden, many countries need to learn from those countries and to pursue their investments for more electrification. At our level, as I told you, we took our responsibilities and we will massively invest in electrification. Tomorrow, with my team, we will be in Norway for the inauguration of our new cable installation vessel called the Aurora. It is now the world's largest vessel to install subsea energy cable at more than 3,000 meter depths everywhere in the world. Aurora will accelerate the installation of what we call energy highways, interconnections, countries to countries, to modernize the electrification, I will say, network. It's a great satisfaction for Nexans. It's a great achievement for the teams to have this leading-edge vessel to support the backbone of tomorrow's Europe economies and worldwide economy. Nexans, next month, will announce as well and open officially the unit, our unique plant in US for wind offshore subsea cable. This plant is located in Charleston, very nice area, Charleston in US. So it's a it's an important moment as well. It will be on the 9th of November with senators, governors, a lot of politics will come over to visit us in Charleston because we are the unique player having subsea cable facilities in US. So those examples, this new vessel, Aurora, this new plant in US, plus all the investment that we are making in Europe, it's all many of other as well disruptive projects that will put Nexans at the forefront of designing on a sustainable electrification for the planet. Because we consider that with 120 years of experience, we are one of the pioneers of electrification. We have born with Edison, Tesla, Westinghouse, those pioneers that need cable to convey the electricity. So thank you very much to be here with us today, to accept this open and free discussion, to be an active part of the sustainable ecosystem because we have a lot of customers, and I'm very, very, very happy to be with you, not virtual, but live, physical in that meeting. Thank you. Let me now introduce Tomas Kåberger from Renewable Energy Institute that will lead this session for us. Thank you very much.
Thank you, and welcome all of you to this day that has been advertised as a climate day. But it will not be a day of IPCC reports and apocalyptic scenarios of climate change. It will be a day of solutions and industrial opportunities. And my task is first to set the scene by describing how these opportunities have evolved over the last few years and why there now is a lot of economically and environmentally sustainable solutions available to those industrial actors who are able to act quickly. And my first picture is by far the worst I will show you. It's actually a bit complicated. But at the same time, it contains the explanation why we have arrived at the point of development where we are today. It was made by a former colleague of mine at Chalmers University of Technology in Göteborg, Claes Otto Wene, and it was published by OECD in the year 2000. And what he had done was to measure or get data on the cost of different electricity generating technologies and how these costs evolved over time, but also over experience. So what he did was publish this book called Experience Curves for Energy Technology Policy, showing that the more you practice, the lower the cost becomes. That is not rocket science. We can understand that that happens. It's called experience curves because if you draw it on a diagram with linear scales, you get a curve. But if you draw it with logarithmic scales, you get straight lines. And straight lines are wonderful because you can almost not avoid extrapolating them, right? You believe it will continue. And in this case, that is justified. These experience curves in logarithmic scales can be extrapolated. We've seen it in many industries over the years. And what he said with this diagram was that if just a few countries continue to subsidize solar and wind while they are still more expensive than conventional thermal technologies, then they will become economically competitive by themselves. And indeed, that is what we have seen over the last decades. Since he published his book, several countries, Germany among them, have generously subsidized renewable electricity to the extent that this curve of wind power actually grew faster in the first 10 years of this century than anyone predicted in the 20th century. I've now asked about 3,000 people on 5 continents if they have any example of a written prognosis, projection, scenario, business plan, or whatever showing a faster growth of wind power in the first decades of this century than the real development, and no one has. Not even Greenpeace managed in 1998. And the reason why the development has been faster than anyone predicted was that no one really believed that China would go from having almost zero wind power in the year 2000 to having more 2005 to have more than anyone else in 2010. And you see China is now by far the country with most wind power. Not per capita though. Sweden is better per capita. We should always remember that in Sweden, per capita. You also see here that Germany was one of the countries that did spend a lot of money on wind power while it was still more expensive than other technologies. But they have contributed to giving the world the opportunity to access low-cost wind power. And the prices really started to appear competitive in the last 5 years. In 2016, a procurement in Morocco resulted in prices of wind power from new wind power installations between $25 and $30 per megawatt hour. And the world record, as far as I know, is still the project operated by Enel in Mexico, where they offer to provide wind power at $17.7 per megawatt hour, with an index for the value of the dollar in the future, but still remarkably low cost already in 2017. We now see a lot of unsubsidized wind power being built, and in Sweden the measure of how much subsidies are required for investors in wind power is the value of the renewable electricity certificates under the compulsory quota system. As you can see, the costs have dropped and they are now virtually zero. So investments are now, decisions are now made without any expectations of subsidies for onshore wind power in Sweden. And the same is true in many other countries in the world now. Offshore wind has a much larger potential than onshore wind, but has generally been seen as terribly expensive. And if we go back only to 2016, when a procurement process was run in the Netherlands, the company then called Dong, now Ørsted, won this bidding process with a bid of a little more than 70 euros per megawatt hour. And that was in the middle of the summer. Then nothing happened in August, but in September, Vattenfall won a similar procurement process off the Danish west coast at a price of only 60 euros per megawatt hour. And then another boring month of October where nothing happened, and in November, Vattenfall won the Kriegers Flak procurement on the Danish east coast at a price below 50 euros per megawatt hour. So you had a linear drop by 10 euros every second month, 5 euros per month per megawatt hour. And again, it's a straight line. And if you extrapolate that, offshore wind power would have been for free by the summer of 2017. In this case, linear extrapolation was not justified. But still, during the spring of 2017, we had the first deal where Energie Baden-Württemberg and again Dong offered to build offshore wind power off the German coast without any guaranteed subsidies. And this was then used by the Dutch government, offering an area and connection to the grid for anyone who was willing to build and guarantee production, but not requiring any subsidies. And then Vattenfall won this contract. And in these cases, there are projects that are now either completed, or in this case, the construction started this summer, and the technology development has been at least as good as expected by these companies. Solar electricity has also enjoyed a dramatic growth. Here, though, there are people in the 20th century who were very optimistic. I seen a German study showing that by 2015, more than 50% of global electricity would come from solar. So this was not totally unexpected, but still a remarkable growth. Both solar and wind have passed nuclear power in global installed capacity in watt, and solar is now trying to catch up with wind and may do so within a few years. But still, the operating hours, average operating hours at full power for wind and solar are different. So it will take a few years more before solar actually delivers more electricity. Again, in solar, we have China as the driving country now. They are by far ahead in installed capacity, and they are also dominating the industries providing the technologies. I think it's in the order of 3/4 or even 4/5 of global production of solar cells now located in China. But again, it's important to note that the credit for this achievement should be attributed to the German households who, during this period in the early years of this century, paid significant subsidies, and they're still paying some of these subsidies for the industrial learning that brought down costs. So especially as a non-German, when I'm in Germany, I keep telling them that the German households we should all be grateful to the German households because they basically saved the world. To illustrate how the costs came down, we can look at how these kind of bidding processes showed result. And again, from 2016, we had the news that a tremendously low bid was achieved in Peru, below 5 cents per kilowatt hour. And this was tremendously low in February, and many people said it would not happen again. But a year later, or a few months later even, Dubai managed to get a bid below 3 cents per kilowatt hour. In 2016, in September, we had a bid below 2.5 cents. And now we come to 2017. We got the first bid now in Mexico below 2 cents per kilowatt hour. We had the first below 1.5 in Portugal in 2019. And we now had, quite recently in April this year, a procurement in Saudi Arabia with a price it's just about $0.01 per kilowatt hour. The dramatic industrial learning resulting in lower cost of solar electricity. And for us in Northern Europe, this is a major challenge, because if electricity can be provided at a total cost of down to 1 cent per kilowatt hour in countries like Saudi Arabia, why should electricity-intensive industry make investments in Northern Europe? That is going to be a challenge for us. But we should also be aware that while Saudi Arabia has more solar insulation than we have, it's not more than roughly a factor 2. So if they can produce at 1 cent per kilowatt hour, we should be able to produce at roughly 2. And if you follow the development of bids in Northern Europe with the way cost came down in the most sunny parts of the world, this fits quite well. We had here in 2016 a little more than 5 cents per kilowatt hour. It fell to 4.5, below 3, again 3.5 cents per kilowatt hour in 2020. But then we don't have any more of these procurements, because what happened is that now solar is comparable in total cost to the average electricity price, and even better, solar electricity is produced during daytime when electricity is generally more valuable than during nighttime, and therefore also during the average. So we see solar plants in large scale being built in Germany, even in Denmark and in Britain. So solar is becoming a relevant source of electricity, not only for rooftops, but also for large-scale installations in Northern Europe. Just to show that this is not only a European phenomena, I thought it was worthwhile showing what has happened in the United States over the last 10 years. We hear a lot about people like Donald Trump saying they like coal. But if you look at reality, we have seen a dramatic transition in the US as well. Coal-based electricity generation in the US fell by 1,000 terawatt hours between 2010 and 2020. Some 500 coal-fired electricity generators were closed. The 5 largest coal mining companies in the US have went bankrupt between 2015 and 2020. Even this guy Murray, who sponsored Donald Trump and liked what he said, went bankrupt during Trump's year in power. So what we see, even if natural gas or fossil gas compensated for some of the loss of coal-fired electricity generation, the net decrease of fossil-based electricity generation was roughly 460 terawatt hours, and renewables increased almost as much. So renewables are substituting fossil fuels also in the US. What is really the most enjoyable opportunity that was very difficult to foresee in the 20th century is how electricity prices have developed compared to the world market prices of fossil fuels. And this is not so easy to discover because we have these strange units for how different fuels and electricity are traded. So when you hear about the world market price of oil, you hear a number in dollars per barrel of oil, and when you hear about electricity, you hear dollars per megawatt hour. So you need to compare them, and that's in a way trivial, but you need to do some multiplication and find some conversion factors. So I made this diagram to make it easy. So I just take the today's price of oil, and I put it into this diagram, and then I convert it immediately to dollars per megawatt hour. And if you look at the price of oil today, it's roughly a little more than $70 per barrel, which is equivalent to $45 per megawatt hour. And that's the energy content of the oil. And we saw the best solar and wind projects being below 20. So oil now, crude oil per unit energy costs twice as much as the cheapest new renewable electricity generation. A wonderful opportunity to use renewable electricity to substitute oil. So what do we see? We see electricity substituting oil. We see it in cars, where Norway had, what was it, 85% of sold cars in Norway in June were electric. We see it in China, where not only for energy economic reasons, but also for local air pollution reasons, the city of Shenzhen have an entirely electric bus fleet now of approximately 20,000 buses. We see electric ferries in Norway and Sweden, and we even see electric aviation. 15 years ago, I was in a panel discussion, and I said that we will never have battery electric airplanes. And there was a very polite, nice young man in the audience who came up to me afterwards with a little note, and he said, check this website. And I checked the website, and there was a Chinese plane manufacturer who was already then, 15 years ago, offering battery electric airplanes for a two-seat aircraft with a range of about 1.5 hours. So it was not really a full commercial airplane, but I was very happy that he did it so discreetly, and I have never since said battery electric aviation is not possible. And I've tried to support Heart Aerospace, which is a Swedish company that has now managed to get a lot of contracts for selling their aircraft, even though they have not yet developed them, but they should within a few years. Another conversion that's even worse is the fantastic unit of trading fossil gas, which is million British thermal units. Anyone who can do in their head a conversion to dollars per megawatt hour? I double-checked this many times. I'm not used to these strange British units. But anyhow, we now have a rather extreme price of fossil gas in many places in the world. And again, the price per unit energy of gas is many times the cost of electricity. Even when fossil gas is down at their normal prices, it's in Europe and Asia often more expensive than the best renewable electricity generators available. So even gas can be substituted by fuels produced from renewable electricity, where hydrogen is the one that is now very popular to discuss. And we see these fantastic numbers of the plans for hydrogen generation in Europe. And even I heard that there is now 1,000 times as much electrolyzer capacity in procurement than the total installed capacity in Europe. So it must be a very nice position to be in to be able to offer electrolyzers in Europe. There are some in Norway who can. Coal is the cheapest of all fossil fuels and still used to produce electricity. Again, we have a very extreme situation just today with coal prices that are at around $170 per ton. Coal is usually traded between sort of $50 and $100 per ton. So it's an extreme situation today. And now, for the first time, I would say, ever, we have a coal energy price that's higher than the best renewable electricity generators. This may not last. It will probably not last. But still, if you also include some sort of carbon pricing that we have in Europe, renewable electricity can also outcompete coal. And that is what we see companies in Sweden betting on when they are developing steel manufacturing processes that uses hydrogen instead of coal. And the first is hybrid, the second one is H2 green steel, and they have similar but not identical processes. And one of the things that they are doing is that they are also planning to be price opportunistic, meaning that they will design the processes so that they will not be dependent on continuous low pricing of electricity, but they will either try to store hydrogen to run the steelmaking process in periods when there is little wind power available, or they will store sponge iron, which may be a cheaper alternative. We don't know. But this makes it possible for these industries to be a part of the flexibility necessary to manage a system with a large share of solar and wind power. The electrification of the transport sector has also resulted in a very impressive learning curves for batteries. While solar PV panels may have decreased in price roughly 75–80% over the last decade, batteries have fallen by 80 or even 90% in price in the same period. Again, by industrial learning, by doing. And batteries are very competitive to manage the daily variation of solar, and they are extremely useful in electricity grids to manage short-term frequency stability and services of the kind traditionally provided by large thermal plants with heavy generators and turbines. And this is one of the technology development areas where it's sometimes frustrating to see how some in the power industry are a little behind the real development. We've had instances in Sweden where managers for large power companies have published articles about how necessary it is to keep the inertia, the mechanical rotation energy in the large power plants, at the same time as even the same power companies win bidding processes for frequency stabilization in other parts of the world with solutions using batteries and power electronics. And we have seen demonstrations of how efficient batteries can be for grid stabilization in Australia, and we see in the US how batteries and renewable electricity is used to substitute the kind of peak power that was previously produced by gas-fired power plants. Pure economic arguments that are a result of technological and industrial development. When I mentioned the importance of flexibility in hydrogen-using industries, being able to use electricity price opportunistic processes, that can also evolve in existing industries. And we have some good examples how industries are benefiting from the variation in electricity price and providing flexibility services via power companies. And this is the collaboration that was announced just a few days ago between a chlorine plant in the Netherlands and Vattenfall, where the chlorine plant is developing their flexibility to stabilize the grid or stabilize electricity prices. And I'm quite sure that we will see a lot more of this in process industries where the processes were traditionally developed for a setting where electricity prices were only offered as a stable price throughout the year, but when the ability to collect measurements now makes it possible to have a pricing strategy where you actually provide price signals to the customers. And if you are to utilize the very cheap solar electricity, you need process industries that can operate during daytime when electricity is very cheap and shut during the night. And of course, this will require some technology development in these process industries, but it's not unfeasible. It's even feasible, and with these price and cost fluctuations, it will become more competitive and utilized in the future. But despite these development of storage and flexibility, grids are valuable when you have a lot of renewable electricity. It's very nice to be able to, during periods of little wind and little solar irradiation, to buy electricity from a nearby region that has the wind blowing and the sun shining. And one of the early scenarios based on this thinking was presented in 1992, not appreciated by everyone in the power industry or even in his own company at the time, by a Swedish engineer, Gunnar Asplund, who worked with ABB power systems in Ludvika and who made a scenario for an entirely renewable electricity system in Europe. And there were 700 gigawatt of solar, 300 gigawatt of wind, 200 gigawatt of hydro, lots of storage at the time, compressed air and solutions like that. But then, of course, a lot of cables, because that was ABB's business at the time. So cables and high voltage direct current installations was what he saw as the solution for a renewable electric-driven Europe. Another similar ambition is developed in China, as some of us know, by an organization now called Global Energy Interconnectors. It is led and inspired by the former president of State Grid, the world's largest electric power company, Zhenya Liu, who's also a member of the Swedish Royal Academy of Engineering Science for what he has done to stimulate engineering development within ABB by placing ambitious orders. But in Gateco, where I've been involved as an advisor also, they have developed now a vision for a global grid. The idea of being able to trade electricity all around the world. It will take a few decades, they say, before this is real, but with the Chinese strategic long-term thinking, this is what they want to achieve. Their idea is based on the fact that cheap renewable electricity will be able to outcompete all other sources of electricity, and it will then be able to substitute fossil fuels in other sectors. And if you're going to operate this in an economically efficient way, you should produce a lot of the renewable electricity where the renewable resources are large, and send it by cables. The fossil share of global electricity generation has, as you see in this diagram, dropped quite fast in the last few years. But this is also a couple of slides that I used to illustrate what Winston Churchill told us. You should never trust any statistics that you have not manipulated yourself. And the reason is that while this looks quite impressive, if you put it on a scale from 0 to 100, you see that there is still a long way to go on even renewables replacing fossil fuels in the electricity sector, and then to increase electricity generation to replace fossil fuels in other sectors. And you can see this as a horrible trouble and difficult, but you can also see it as a lot of profitable investment opportunities, right? But the situation today is that we are still dependent on a lot of fossil-based electricity generation in Europe. And not only is gas expensive and coal expensive, for some reason, which few people can explain, also carbon emission allowances are very expensive at the same time. So what is the result? Very high electricity prices throughout Europe. We can enjoy the fact that even in Stockholm, the price of 114 euros per megawatt hour is relatively low. It's even more expensive in Oslo. It's a lot more expensive in Malmö and Copenhagen. And it's about 35 euros more expensive in Belgium, Holland, and France. And it's a lot more expensive in Britain, where they also have some problems with power lines not being operational in relation to France. So again, you can look at this as a horrible situation. You can also see, lots of wonderful investment opportunities. Just look at this price difference, what you can do with a power line. Or look at these high prices compared to cheap renewables. See what you can do with offshore wind power. So if you have this attitude that it is an opportunity, we could also see how it's reflected in Swedish media in the last 2 days. Yesterday we had this opinion article by the managing directors of some of the major electricity using companies in Dagens Industri saying that we should speed up the development of wind power. And we had today, this morning, the projection by one of the bank experts that the demand for carbon-free steel will be very large compared to the supply in the coming years. So no doubt there are opportunities and we have technologies available. So there is a lot to do in the coming years for this electricity industry to make the 21st century another century of electrification beyond the kind of electrification that was achieved in the 20th century, because now we can substitute fossil fuels in sectors which was impossible in an era where fossil fuels were used to produce electricity. I hope this will inspire the day. We will have several panels discussing these opportunities, but first of all, a coffee break. So we'll start again at 10 o'clock with the first session. Thank you.